once again, we see a large range of uncertainty. And to me, I do not feel that this is the most accurate representation of climate history of the last millennium that's available. For one, many of the independent studies that are listed are not really all that independent. We have a number of other data sets from man's group himself. Two of them are actually borehole reconstruction. Boreholes are basically cores that are dug into the earth and record temperature deep down into the earth. And they only go back to the year 1500. So it's obvious that these cannot be used to conclude that the 20th century was the warmest time in the last millennium, if they only go back 500 years. So it's a mystery to me why these even appear at all. Anyways, most of the data sets here are they seem to be selected for their hockey stick-like properties. But in summary, I don't really feel that this is the best temperature reconstruction available. Instead, I'm going to show you how I reconstruct the temperature of the last 1,000 years. And for start, this is oxygen isotope proxy data from the Greenland ice cores. It's out of a book called Ice Ages and Astronomical Causes by Gordon MacDonald and Richard Muller of Berkeley. And here we clearly see a medieval warm period occurring around the year 1000, and clearly a little ice age from about the 14th century to the 19th century. The modern era is no longer the warmest time in the last 1,000 years. We also see warm times during the Roman era. So this is from about 400 BC to the year 2000. Temperature seems to vary quite significantly. The next one I want to show you is an ice core record. It's also oxygen isotope proxy data from the Quilcaya Glacier in the Peruvian Andes, clearly demonstrating warmer temperatures during the medieval ages and the occurrence of a little ice age in the 16th century to the 19th century. And finally, I have also an ice core record from Antarctica. This is from the European project of ice coring in Antarctica, and it is from the period of about 3000 BC to the present day. Once again, medieval warm period is clearly indicated around the early centuries of the millennium, and the little ice age in the later centuries, followed by the current warming to where we are today. Okay, so medieval warm period is seen in both polar regions and the tropics. Now, we don't have to stop the analysis there. We can keep examining lots of records from other parts of the world, but unfortunately I have to stop there because I'm running out of time. So, in conclusion, I wrote them down because I thought I was going to forget them. It appears that climate varies naturally over time on the order of a few degrees Celsius. And the traditional explanation for this is solar variation. So, and a recent publication by a group of astrophysicists has described that, according to their research, the sun is unusually more active in the recent decades than any other time in the last 1,000 years. So that's from this article, Physical Review Letters 2003. So, given that, if we want to think about the future of climate, I'd like to ask the question, what is the future of solar activity? And I'd be happy to answer any other questions you might have. I think I can answer a few questions now, and then Albert's going to introduce the video presentation of the global warming swindle. But thank you so much for coming to my presentation, and I hope you enjoyed it. Well, that's what I read anyway.
It's
Yes?
it's land surface, and that's why it's subject to the heat island cap.
Okay, my mistake. Yeah, sorry, I must have misread something. Thanks. Yes?
You might look at extending that past 1,000 years ago, because there are comments in some of the graphs that I have that are suggested that the current last 50 years of solar activity is, if not the highest, among the highest in the last 8,000 years.
Really?
Yeah. So it's that paper there. Maybe you saw Solanke was in that one as
Yep.
well, I think. But they have a longer term one that goes back 11,000 years as a data series. And again, the further you go back, the more you start asking questions about the reliability of the proxies. But it is indicative of that anyway. So that might be interesting to show.
Okay.
I remember in Tim Patterson's talk at his luncheon, he went a little bit further in what he said as he talked about these different cycles and gave him numbers like points 24 or something right now.
Yeah.
And then he says actually by the time we get to 25, he said watch our probably head for cooling. I don't know what.
Yeah, I wasn't going to make any predictions.
2022 is
Yeah, something else.
Absudimov and Hathaway, David Hathaway at NASA, and Absudimov in Russia.
How do they actually, I mean, without taking up too much time, how do they actually do that?
Well, I think the big advance in the last 10 to 20 years, as I understand it, for predictability has been helioseismology, where they're actually monitoring seismic waves on the surface of the sun. And by doing that, what they've been able to do over a length of time is have enough data to be able to gain predictability about the next cycle. But it only really goes out, as I understand it, to any degree of reliability, one cycle, one half cycle. As a full cycle is 22 years, 11-year roughly foot poles. And actually at the beginning of May, French scientists and Canada's David Thompson at Queen's University have just published more about picking up internal, very deep solar modes of vibration, G modes. And David Thompson's been talking about that, so hang on to your seat, because they may get even, there may be some really surprising stuff come out of that over the next 20 years, but it'll probably take time.